We're going to go ahead and consider the implications of parallel and perpendicular lines and how it deals with slope today. Now we say that two lines with the same slope are actually parallel to one another. Perpendicular lines have slopes which are opposites and reciprocals. Now, in layman's terms, that just means if you start with a given slope, you should change the sign to its opposite, and reciprocal just means to flip the fraction. Now, let's look at an example. This first example will ask us to use a parallel line. So with a parallel line, again, we need to recall that that would be the same slope. So it says write that in point slope form. So it would be y minus y1 equals m times x minus x1. That's the point slope form. The x1, y1 would be the numbers given. So I have y minus 5, and then I have x minus that negative 2. The slope is going to be right here in front of the x of the line that we're comparing it to. So whatever that slope is, that's what I'll use for my same slope. Now if I just take care of my double negative, I would have y minus 5 equals 3 times x plus 2. This would be the answer in point slope form. Now the second part of this problem asks us to write it into the slope-intercept form. So I will take this answer, y minus 5 equals 3 times x plus 2, and I will solve it for my y. So I'll have y minus 5. I use a distributive property to get 3x plus 6. Move that 5 over and it becomes a positive. So I have 3x plus 11. That would be my answer in slope-intercept form. And that's how to use same slope with parallel. Let's take a look at perpendicular. Now, I still have my x1, y1, and this time the line that I'm comparing it to, the slope, the original slope, let me write it that way because that comes in the original problem. The original slope is 1/3. What I need to do is change the sign and flip the fraction. So to get a perpendicular slope, I would make that a negative 3/1. Now negative 3/1 is the same thing as negative 3. So I could just use that for my slope. Again, if I do my point slope, y minus y1 equals m times x minus x1. I substitute in my x1 and y1 and my slope. So I have y minus negative 4. I have a negative 3, x minus 2. I take care of my double negatives to get y plus 4 equals negative 3 times x minus 2. This would be my answer in point slope version. If I wanted it in slope-intercept, I would take this problem and solve it. So I would do the distributive property to get negative 3x plus 6. Then I move that 4 over and it becomes a negative 4. So y equals negative 3x plus 2. That would be my answer in slope-intercept. And that's how you find lines that have either parallel or perpendicular slopes.